In Module 8, we're going to talk about resource management and monitoring. Although the VM kernel works proactively to avoid resource contention, maximizing performance requires both analysis and ongoing monitoring. So it does report back and does a good job of it, but we still have to have some human intervention to make some decisions for us. There's 5 lessons in this module. In Lesson 1, virtual CPU and memory concepts. After this lesson, you should be able to discuss memory and CPU concepts in a virtualized environment, describe overcommitment of what a resource means, what overcommitment of a resource means, identify additional technologies that can improve memory utilization, and describe how vSphere virtual symmetric multiprocessing works and how hyperthreading is used by the VM kernel. The basics of memory utilization. So the guest operating system is virtual memory is presented to the applications by the operating system. The guest operating system physical memory is presented to the virtual machine by the VM kernel. So the VM kernel takes from the hardware and says you have this much memory. Host machine memory that is managed by the VM kernel provides a continuous addressable memory space that's used by the virtual machine. So the VM kernel carves out the memory from the host and sets it aside for the guest operating system. Now, memory overcommitment, what we have is when you create a virtual machine, it'll create a swap file, and it's a .vswp file. What happens is, let's say we have 2 gigs of RAM in a machine, but applications start using more than 2 gig. It'll actually overcommit that and it'll swap it out. Just like on Windows and Linux. Windows has a page file, Linux has a swap volume. So like in Windows, your page file, when you start running low on memory, it will start swapping out to a file. And that gives you more memory than you actually have. Same thing with VMware, but you got to look at it as the ESXi host is swapping out memory. Even though it may have memory available, it's not allocated for that virtual machine. So when that virtual machine starts using more, it starts swapping on its swap file. We can also use memory reclamation. So what happens is we have physical memory pages. TPS, or transparent page sharing, it allows pages with identical contents to be stored only once. Great example I like to use is Windows always has Explorer.exe running. Well, if it's the same version of Windows, same build, same patches where Explorer hadn't been patched, TPS knows that, oh, you got 2 Windows virtual machines running. Well, here in memory, Explorer.exe is the same file, taking up the same amount of memory. So I'm just going to basically use a pointer, kind of like deduplication in a way. What's going to happen, it's not going to, let's say Explorer's taking up 40 meg, probably more than that, but let's just say 40 meg. On the next virtual machine, it won't be taking up anything because it'll point it back to the Explorer.exe that's running on the other one. Another way is we can deallocate memory from one machine to another. This is referred to as the ballooning mechanism. And what happens when memory gets really scarce, it tells virtual machines to use their own paging areas. And what will happen, you have to have VMware tools installed. It'll actually go into the OS and start reclaiming memory from that virtual machine. Another feature is memory compression, and this will attempt to gain some memory. When it's high, it'll start compressing memory. And we can also do host level SSD swapping. And what we can do here is we can have basically set up a host cache, and we have some SSDs. It'll start swapping the virtual machine, but it'll store the swap file on a solid state drive so it's quicker. And then of course we have the swap file it'll page out the disk. It does this last because it is the worst performance. Next, we'll talk about virtual SMP or symmetric multiprocessing. So in a physical system, SMP is used when we have more than one physical processor. Well, even logical processors, because we have cores now. It uses SMP. It allows the operating system to talk to multiple processors. Same thing, we do it with virtual. As you can see in this example, we have maybe just one vCPU, but we might have two logical CPUs. Dual core, dual system, or dual socket, and this one would be we actually have two physical CPUs, and we assign two logical processors, or each vCPU. I'm backwards. And then let's say we have a quad core single socket system, so we have four processors, so we can align four vCPUs, take up each processor. And then we talk about hyperthreading. Hyperthreading will enable a core to execute two threads or sets of instructions at a time. So we can have one VM with one CPU, and notice the CPUs, they have to match up. Like if I had one actual core in one system, I can't give it two CPUs. It's going to have to match up to another one. But what I can do, especially this is what hyperthreading helps, here's a VM with one processor, here's one with two. But as we can see, these two are shared. And this is where hyperthread is going to help, because it can execute two threads at a time. So we get an instruction set from this one, it can also take one from that one. So we're not completely loading down that CPU. To enable hyperthreading, you have to have a host that supports it. You enable it in the BIOS, and then you can ensure hyperthreading is turned on in ESXi. And ESXi is on by default. Now, years ago, I don't even know if it was version 3 of vSphere, but I know version 3 and 2.0 and 3.5, we were instructed as engineers to disable hyperthreading. It actually slowed it down, but they've got that figured out on newer systems. We also can do load balancing. So as you can see in this example, everything stays on a different processor and it keeps the load around. But now yeah, each one of these are union dual, but see how it's keeping them separate? It keeps its load around. If we added another system here with two processors, they would get distributed. It's not that way. It tries its best not to load the CPUs down. You should now be able to discuss CPU and memory concepts in a virtualized environment, describe what overcommitment of resources are, and identify additional technologies that can improve memory utilization, and describe how virtual SMP works and how hyperthreading is used by the VM kernel.